Hey everybody, Dan here, and welcome to the channel. Today I'm super excited because I get to show you how to make this traffic simulation from scratch. So I'm going to walk you step by step how to make this with JavaScript and Three.js. So before we dive into the code, let's go take a look at the final product and see what we're going to be building. So I just have a blank city right here. So let's zoom in a little bit and start laying down some roads. We'll do an intersection here. Wrap this around here. You can already see we have some cars starting to pop into view. I just laid out kind of a arbitrary road system here. So how exactly is this traffic simulation working? So I've added a little visual tool to help explain this a bit more and show what's going on behind the scenes. So I'm going to go into the console here, and I have a little vehicle graph helper. I'll set the visibility to true. And now we can actually see what's going on. So what just popped up on screen here is called the vehicle graph. Now a graph, for those of you that don't know, it's a computer science concept. And it's pretty simple. It's just a series of nodes, and those nodes are connected together with edges. Now the edges only go in one direction. So if an edge goes from node A to node B, you can't travel back to node A along that edge. So all the key points where a car would kind of make a maneuver, that's where I put the nodes. And those are represented by these green low poly circles here. And of course, the edges are represented in blue. So what I've done for each tile type, so we have corners, we have the four-way intersection, the three-way intersection, straight roads. We also have the dead end road here. So I've laid out I guess we can call it a subgraph for each one of these tiles. When we're building out the road system, when we're laying the tiles down, we're connecting these little subgraphs together or taking them apart and putting in a new subgraph. So you can see, let's say I delete this three-way intersection in the middle right here. You can see all the neighboring tiles had to update their connections to account for this tile now being gone. So I think I've rambled on enough here. Let's go and start looking at how to code this up. Alrighty, so I have my VS Code up. We are ready to rock and roll. So there's a lot of places I could begin, but I think what I'm going to do first is we're going to add the car 3D models in. That's kind of the simplest thing to start with. So I've already added kind of all the models that came with that PolyPerfect city pack. So in the previous video, I kind of showed you how I implemented those new models, and all those models are under here. And I scroll down and you can see there's a whole bunch of cars here. So we have a veteran car, taxi, police car, passenger van, a whole bunch of stuff. So we're going to import, say, like 10 of these vehicles, and then we'll create a function in our asset manager where we can randomly choose one. So the first thing we need to go and do is locate the models file that contains the metadata for all of our models. I'm going to go ahead and add all of the vehicles in here. All right, so I went ahead and added the vehicles. So you can see I also added a type here, so you can easily filter on the list of all the models down by type. So you can see I've added a taxi, a police car, passenger van, and I've also specified the rotation for each car. So this is just so that the front part of the car is aligned with the forward direction. And based on how these were modeled, I needed to add a 90-degree offset to all of these. So we have our models all set up in our models file. Let's now go into the asset manager. And we're going to create a new method that'll give us a random vehicle mesh. So I've scrolled down a bit where we're creating the road mesh. So I'm going to create a new method here called create random vehicle mesh. No inputs for this one. We're going to start by gathering all of the different types of vehicles that we have. And those are going to be basically these key identifiers here. So we want to filter down our list of models and get all of the ones that are of type vehicle. So we'll say types is equal to, and then I'm going to get all of the entries in our array of meshes. Then we're going to filter that down. So this actually returns an array where the first entry is the key and the second entry is the value. So this would be the key and then the object is the value. So I want to look at the value and I want to get all of the models that have type vehicle. And then I'm going to do a map here. Then I'm going to return the key. We can do console.log types, help us debug that. And then we need to just pick a random type and then return that mesh. So we'll get a random index here. We'll take the floor types.length times math.random. And then we will return the mesh of this name. And we're going to fade the cars in and out. So in our clone mesh function, we want to set transparent to true. And what that does, it just traverses through the hierarchy of the mesh. So our vehicle meshes are actually broken down into multiple submeshes. The body and the wheels are all separate meshes underneath a parent mesh. So that we set the material on all those submeshes to transparent. Okay, so now we have included our car models. We've created a method on our asset manager that allows us to pick one of those random vehicle meshes. So got that part out of the way. Now we can go and focus on actually creating the vehicle graph. So I'm going to go ahead and create a new folder here. And let's call it vehicles. So we're going to be creating a bunch of different files here. And we're going to gather them all under this vehicles folder. So let's start by creating our vehicle graph. So as always, we're going to import our Three.js dependency. And let's create a new class called vehicle graph. Now you can see that I am inheriting our vehicle graph from the Three.js group. Now what is a group? A group really is just a kind of a node in our scene that allows us to collect all of our objects together. So all of our little parts of our graph, all the different nodes, the vehicles, those are all going to live under this vehicle graph. And then that's going to be one node that we can then add to our scene, and that'll pull along the graph and all the vehicles with it. Let's create a constructor here, and we're going to pass in the size of our city and also a reference to the asset manager. So when we need to go ahead and spawn new vehicles, we can go ahead and ask the asset manager to get a random vehicle mesh. So in subclassing, we always need to call the constructor of the superclass first. So we'll add that. And then we're going to keep references to the size and the asset manager with our vehicle graph object. Now, as I discussed previously, we're actually representing our graph by breaking it down into tiles. So I'm going to create a new property called tiles. This is going to be a 2D array. And it's going to be a 2D array of vehicle graph tiles. So quickly going to go and create a new class here. So we'll finish up the implementation for this later. But right now we can add a little JS doc here and say this is of type vehicle graph tile and make it a 2D array. Now we need to initialize this 2D graph to the size of our city. Let's go ahead and do a nested for loop here. All right, so I've gone ahead and created the code that will initialize our vehicle graph. It's simply a nested for loop. We're building it column by column, and then we're appending those columns to our 2D tiles array here to create the full matrix. So we're just passing in null values for now. So when we add roads to our city, we're going to go ahead and replace that particular tile with the subgraph for that road. But to start with, we don't have any roads, so this is just going to be null. So let's also create a little helper function while we're here called getTile. And this will get the tile at the X and Y coordinates. And we can put some error handling in here, some validation. So if you pass in some invalid coordinates, it won't crash the application. So the JS doc always helps me to kind of code when I'm working on this, just to seeing what the types are and get that IntelliSense. Really should be using TypeScript. I don't recommend using JS doc over TypeScript, but I didn't want to switch to TypeScript halfway through this project and confuse all of you. So that's why I'm using JS doc. This is going to be a vehicle graph tile. And I will save the descriptions for later. All right, so that is the basic implementation, kind of the very basic structure of our graph. Let's go and flesh out our graph tiles a bit more. So we're going to start with something a bit easier. We're just going to have one node per tile, and then we'll connect those together. We'll kind of get that working. And then later on, we'll add our kind of fully fledged subgraphs for each of our different road types. So we're just going to have a node property. That's going to be a single node on the tile. And before we can do that, we need to go ahead and, create a new file here that lets me. This is going to be vehicle graph node. And I'm going to just make this a mesh. Then a constructor here, call the constructor of the superclass. I'm going to pass in some X and Y coordinates, and we'll set the position of this node to those X and Y coordinates. So since this is a graph, our nodes need to keep track of which nodes they are connected to. So I'm going to create an array called next. And this is going to be of type vehicle graph node. That's an array. So let's create some functions that allow us to connect this node to another node and also just completely erase all the connections. Let's add a function called connect and pass in a node. If the node is null, we'll just ignore it. And then we also need to make sure that we're not already connected to that node. So if next does not include the node, then we can go ahead and push that node onto the next array. We really don't want to keep more than one reference to a node. There's just no reason to, and it creates some weird bugs. So let's create one more method called disconnect to all. All this does is just set next to an empty array. So basically, when we're removing a tile or the subgraph with that tile from the vehicle graph, we need to disconnect all those nodes. So kind of breaking all those connections before we pluck that thing out. All right, so that's really the gist of the graph node. That's sort of the basic structure. So let's go back to our tile and we'll set this to a new vehicle graph node. I'm just going to set the X and Y position to 0. Now we need to be able to visualize everything. So let's add some geometry to this vehicle graph node. So this geometry equals, let's do sphere geometry, make the radius small, and I don't use too many polygons here, so we'll keep the segments 6 and 6. And the material is going to be, let's see here, let's do new 3.mesh basic material. And the color, we'll just make it, I don't know, red for now. So we have our nodes here, we have our tiles, and we have our graph. Now, in order to get everything to render properly, we need to be able to add all of this to our scene. So our scene manager is actually going to be keeping track of our vehicle graph. It's going to maintain sort of that original reference. So let's go down to where we're initializing our scene. And let's create a new vehicle graph. And this is going to be our vehicle graph. So we'll pass in the size of the city and a reference to the asset manager. And then let's add that to the scene. Actually need to add it to the root node. So I have the kind of the grid overlay in a separate node so that the kind of the user interaction, the raycasting doesn't intersect with that. So all of the interactive stuff is underneath this root node. So we'll add our vehicle graph there. So the vehicle graph is now part of our scene. It can be rendered. So as sort of a first step here before we get to the more complicated tiles, like I said, we're going to use these basic tiles that just have a single node on them. So I'm actually going to create a tile here, the vehicle graph tile. And we need to pass in the X and Y coordinates to that tile so that tile knows where it is. Add that in, and then in our graph tile, we will set the, first we need to pass in the X and Y coordinates in the constructor, and then we'll set the position to those X and Y coordinates. Now going back to our vehicle graph, we're going to add this tile to the 2D array, and we're also going to add it directly to the graph itself. And so that way the tile is included in the scene hierarchy. So we just do this dot add and the tile right there. We're going to restructure this a bit later on, but I'm trying to keep this simple and sort of ease us into this whole graph concept. So similarly, we need to go into our graph tile, and we need to add the node to the group. Because just assigning it to a node property on the tile does not add it to our Three.js scene. We'll add the node here. And we need to make sure we add the .js suffix here, or the browser will complain. Make sure all these are set properly. When the VS Code does the auto imports, it doesn't add that in for some reason. I kind of wish it would, but such is life. Okay, so we've set up our graph, and the graph has the tiles, and the tile contains a node. We've added all that to our scene. Let's go take a look at our game and see if we can see anything. And it looks like we forgot to call, we forgot to call the super constructor for our vehicle graph tile. Let's go ahead and add that call in. Clear that out and refresh. So another tweak we need to make here, I forgot to add this to node. Add that in. And go back to our browser. Okay, we can see that our scene finally loaded. Let me close the console here. So we've created a tile at every location in our city. And we can see the graph node for each tile located here in the center. So I think those are a little big. Let's go ahead and set this to 0.05. All right, that's a little better. So this is very basic right now. We just have our graph with the tiles and the nodes, but the nodes aren't connected together. So we can't really call it a graph yet, it's just points. So what we need to do is to get these graph nodes connected together. And I think we'll just start by randomly connecting them together, or maybe just connect all of them together. And we'll get a vehicle, kind of a basic vehicle to travel along the graph. And that'll be our first starting point. So let's go back to the code and work on that. Okay, to get started, we're going to just randomly connect our different graph tiles together. And each graph tile, remember, has one node. So just be randomly connecting those root nodes. So I'm going to loop over all of our tiles after we have initialized our tiles array. And what I'm going to do is for each tile, I'm going to get its left, right, top, and bottom neighbors, and I'll just randomly connect those together. All right, so we have references to the left, right, top, and bottom tiles. So we'll just randomly assign those connections, just a 50% chance. So if the left node exists and math.random is greater than 0.5, then first let's get a reference to this tile. Just get tile XY. So if the left node exists and 50% chance, then tile, and then we need to get the node on that tile, and we're going to connect it to the node on the left tile. So we'll do this for the right, the top, and the bottom as well. Now let's go back to our game, and we can see that nothing has changed. And the reason for that is we aren't visualizing the connections between the nodes. So what we're actually going to do is we're going to create a new file called vehicle graph helper. This is similar to other helper classes in Three.js. It's going to be a visualization tool that we use to kind of render and visualize the vehicle graph. But what we will need is an update function. So this is going to take a vehicle graph. Oops. And it's going to generate a bunch of meshes to represent that graph. I'm going to first define a couple different geometries and materials. So I'm going to find a node geometry. What's actually going to be this geometry that we used for a node here. So we're no longer going to render this node. I just kind of set that as a mesh for demonstration purposes. This graph helper is going to be the thing that's drawing everything. Now we also need to define our edge geometry. And that's going to be a cone. You want to give that a very small radius of 0.02, a height of 1, and we'll just use 6 sides for that. Let's change this to, let's make an object 3D because it doesn't have any actual 3D representation anymore. And we can get rid of these. It's just very bare bones. We can close that. So we're going to need 3 different materials. We're going to need one for the edges. We'll just make the edges just a plain old blue. And then we need 2 materials for the nodes. One of those materials is going to be when the node has other nodes it's connected to. If a node has no connections or the next array is empty, then we'll paint it a different color. So let's first define our edge material. This is going to be just a mesh basic material. And the color is going to be, let's see, kind of a lighter blue. And then for the connected node material, we'll do another color. When it's connected, we'll make it green, which is this in hex. And then a disconnected material, and that will be red. All right, so we pass in our graph to this update method. We're going to start by clearing all of the existing children of our vehicle graph helper. And now we're going to loop through each tile in our graph, and we're going to add the representation for that tile. I'm just going to steal this. I hate typing it over and over again. And loop over the graph. And then tile is equal to graph get tile at those X and Y coordinates. So if there is no tile, let me just continue. Otherwise, we're going to draw that node. So let's create another function down here called create node visualization. And then we will pass in our node on our tile. So in this function, we're going to visualize the node and then all of the edges emanating from that node. So I'm going to create a node mesh here. And the geometry is going to be our node geometry. And the material we're going to change depending on whether that node has connections or not. If our node has connections, then we're going to use the connected material. Otherwise, we'll use the disconnected material. And then we need to set the position of the node. So how we're going to do that, I'm going to create a variable called node world position. This is going to be a vector. It's a little bit weird how Three.js does this, but we have to work with it. So for my node, and remember this is the node on the tile, I want to get the world position. And I'll explain what this is in a bit. So when you get world position, this has one argument that we pass in, one parameter, and the result from this function gets copied into this vector. So we create the vector, we pass it into get world position, it copies the world position into this vector. So it's kind of a two-step process to get the world position. So what is world position and why do we need to do this? And that's a great question. So when we're setting up our scene hierarchy, the thing in Three.js is that each child inherits the transform of his parent. And what's a transform? A transform is position, rotation, and scale. So let's say I have my parent node, and that's at the coordinates 5, 5, and 5. So x of 5, y 5, z of 5. Now if I add a child object to that parent, and I give that child a position of 0, 0, 0, its actual position in the world is going to be 5, 5, 5, because it's inheriting its parent position. So if I were to set the child's position to x of 5, y of 5, z of 5, that gets added onto the parent position. So it'd be 10, 10, 10. So what I'm doing here is in my graph helper, I'm just kind of adding everything into a top level node that just sits at the origin. So in order to get the node in the right place, I need to get its actual position in the world, not relative to the tile that it's under. I know that's a bit confusing, but it's really the best I can explain it. So moving forward, actually before we do that, I need to set the position of our node, the node mesh. So position set, and then we're going to set its position x, y, z to node world position.x, node world position.y, and .z. And then we need to add this node. So before we do the edges, let's just make sure that all of this is working correctly. So we need to add our vehicle graph helper to our vehicle graph. On our vehicle graph, let's go back to the constructor and let's create a new property called helper. That will be a new graph helper. Add a type declaration. And then we need to add the helper so that it actually renders properly. So after we initialize all of our graph tiles at the very bottom here of our constructor, do this .helper.update, and then we'll pass in the vehicle graph. So this will generate that visualization of our vehicle graph. So let's see if this actually works. We should get the same result as before. Nothing's shown up here, so I think we have an error. And the VS Code auto imports bite me again. Need to add .js to these. Right, go back. And forget this every time, calling super. I don't think we need that at all. And there we go. All right, so just to remind you, going back to the code here, let's look at our vehicle graph. So we've connected all of our nodes together in some random configuration. So we can see that some of our nodes actually have no connections at all. So due to the random chance, they just got left out of that sort of graph connection process. So now what we need to do is to visualize these connections. So we know that our graph helper is visualizing our graph correctly. Let's go and render those edges now. So I'm warning you, this is going to involve a little bit of 3D math. So I apologize if it's a bit complex, but that's just the name of the game when you work with 3D. So this is where we add edge visualizations for the connected nodes. So for each connected node, so next node of node.next, so we need to get the world position of that node. So next world position, you know what, I'm just going to call this next. Keep it short. So next world position, I'm going to copy it into this vector. So get world position of the next node. Now we need to get the vector between the origin node and the next node. What we're going to do there, we're going to create a new variable called edge vector. So we're going to copy next world position into this. Oops, missed that part. So the copy function copies the value of the argument into this vector. Three.js is pretty verbose when you're handling vectors, but what can we do? So then we need to subtract or sub the node world position. So this is going to be a vector that originates at our starting node and then will point to the next node. So let's just start with this. Let's add this edge, and we need to create a mesh for our edge mesh. This is going to be a new 3.mesh, and the geometry will be our edge geometry and our edge material. So we need to set the position of our edge mesh to the starting point. And that's going to be the world position of our first node. Just copy this here. And then we need to rotate this edge to point to this direction that we've defined here. So Three.js actually has a cool function we can use to get our edge to point in the right direction. So the edge mesh quaternion. So a quaternion is a way to represent a rotation. We can say set from unit vectors. So a cone is initially pointing up. So we'll create a new vector called up. We're not going to call it anything. I'm just going to define it here. And for the sake of saving memory, you can just define a constant up here called up. Going back down here, we want to rotate from up to our edge vector. And we want to clone it and then normalize it to give it a length of 1. All right, so let's see what that gives us. So we have something here, but it doesn't look quite right. Let's see if we can go to the edges here. So it looks like it's creating our edges, but our cone is sort of centered in the middle of it. So really we want to take this whole cone here and we want to shift it all the way kind of down this way. So we need to add an offset so that the origin of the cone is in the right place. Everything else looks pretty good. So we can calculate an offset using the similar approach. So the first thing we need is to get the distance that we need to shift. So this will be the length of our edge vector. So however long this edge vector is, we need to shift it by half of its length in the correct direction. So this offset is going to be a new vector. And it's going to be half of the distance. And then we need to rotate that offset in the direction of the edge. So I apologize. I know this is quite complicated, but working with 3D math always is, unfortunately. And then we're going to add this offset to our position. All right, so what we're doing here is basically our cone starts off pointing upwards, and it's sort of sitting at the halfway height of that cone. So we need to offset that cone so that the bottom of the cone is touching our origin point. So we start with a vector that's pointing up halfway the height of our cone, and then we're rotating that offset in the direction of that edge, and we're adding it here. So in the end, let's see, don't have any errors. Edge is not defined. So we want edge mesh. So there, you can see that our edges are now starting in the correct location. So I'm going to tweak this slightly, make our edges a little fatter at the bottom. It's a bit easier to see what direction they're pointing in now. So in some cases like this, we have an edge going from one node and then another edge going from the other node. They kind of, get skinny in the middle here and get big again. That's why that's going on. So that's not going to be the case with our roads. But if we just have an edge going in one direction, then we can see we have that correct pointing here. All right, so we have a kind of arbitrary graph that we've defined. We have a whole bunch of nodes, basically one node for each tile, and we've connected these nodes together in some arbitrary fashion. So we're getting one step closer to where we need to be. One final thing that we need to do, and this will matter later on, is we need to scale that edge by its length. Right now, the length is always 1. That won't always be the case. So prior to setting the rotation, we set the scale. So the X and Z scales remain the same. We need to scale by the distance. All right, so that is it. This is the finished graph helper that'll help us render our graph. We won't need to change this at all later on when we move to more complex graph. This will suit us just fine throughout the rest of the video. So we can close that out. And one cool thing we can do is we can navigate kind of down this object chain here. So the game has a reference to our scene manager, which has a reference to our vehicle graph, which has a reference to the helper. And because it's a Three.js object, we can set the visibility to false. Likewise, we can set it back to true. So we can go in the console here and, based on if we're debugging or just playing the game, we can turn that on and off, which I think is kind of nice. All right, so now that we have a graph, let's create some vehicles that can actually navigate on the graph. And that'll be really cool once you get that working. Okay, so we're going to go ahead and add one last file. Promise this is the last one. And this is going to be our vehicle. Let's go ahead and define our class. It'll just be vehicle. And then we're going to have a constructor function. We're going to pass in an origin, a destination, and the mesh for the vehicle. So how these vehicles are going to traverse our graph is they're going to have a reference to two different nodes. We're going to have the originating node and then a destination node. So there's going to be some predetermined amount of time, some vehicle speed that's going to dictate how fast they travel between the origin and the destination. So we can define that as one cycle. So at t = 0, we start at the origin, and at the end of a cycle, we end up at the destination. So you're going to hear me talk about the concept of a cycle a lot, and that's what I mean. The cycle is one cycle from the origin to the destination. Then that destination becomes the new origin, and we pick a new destination, and the process starts all over again. So let's start off by calling super, and then we want to keep track of when this vehicle was created so we can kind of set a lifetime to it. We'll say created time equals date.now. And then we also need a cycle start time. This is going to start as our created time. Then we need to maintain a reference to the origin and destination. So these are going to be nodes. And then we need to add the mesh that was passed in. Right, so our vehicle is also going to need an update method. And in the update method is where we're going to put all the logic for updating the position and rotation of the vehicle each frame. So this method is going to be called a lot, so we need to keep it fairly lightweight. We have a basic vehicle defined here. And before we really get into the guts of this update method, let's go back to our vehicle graph and let's create some logic to spawn vehicles. So let's go down the bottom here and create a method called spawn vehicle. So in spawn vehicle, if we haven't met our maximum limit of cars, we want to go ahead and create a new vehicle, add it to the scene. So we need to set a few of these constants first, like the maximum number of vehicles, the vehicle speed, vehicle lifetime. Let's go into our config file. Let's create a new section called vehicle. So I'm going to define the vehicle speed. This is going to be a very small number. So this is the distance traveled per millisecond. So the times that we're working in are in milliseconds. So that's why I'm setting the speed like this. But if converted into seconds, we're saying that the vehicle can travel 1/2 the unit in 1 second. So it really takes 2 seconds for a vehicle to travel between each tile. Now we're also going to set our fade time. So this is the amount of time in the beginning and end of the vehicle's lifetime where it'll fade in and fade out. We'll set that to 1,000 milliseconds. This is the start end time where the vehicle should fade. And then we want to set the maximum lifetime, let's say 10 seconds. And then our max vehicle count, let's set that to 1 for now. So we'll just work with 1 vehicle. And then let's set our spawn interval. So this is going to be how often that spawn vehicle method will get called. We're going to call it once every second. It'll check to see if any vehicles have disappeared yet. And if there's room for another one, then it'll go ahead and create a new one. All right, so those are all the constants that we need. So we can close this for good. All right, so let's get back to working on our spawn vehicle function. So before we can spawn any vehicles, after we generate them, we need a place to put them, and they need to be added to the scene. So let's add a new property on our vehicle graph called vehicles. And this is going to be a group. And then we need to make sure to add that group to our vehicle graph so the vehicles actually get rendered. So let's go back down here. So if this dot vehicles dot children dot length is less than, and we'll use the new variable we defined in our config file. So we need to go ahead and import our config file up here. So if config dot vehicle dot max vehicle count. So if the number of vehicles in our scene is less than the maximum vehicle count, then we want to go ahead and spawn a vehicle. We need a place to actually spawn the vehicle. So we need to find some random tile on the map, some road, and just pick a random node on that tile, and we'll generate a vehicle at that location. And from there, it can go and drive wherever it wants to. So we need to create another function down here called, say, get starting tile. So this isn't necessarily the most efficient way of doing this, but we're going to loop over every tile in our vehicle graph, and we're going to find all of the non-null tiles, and then we're going to pick a random one of those. So since spawn vehicle is only getting called once every second, this really, I don't think is too much of a problem. If it was getting called very frequently, then we'd probably want to cache the tiles in a separate data structure so we're not iterating over the entire 2D array every time. But I think this will work well enough for now. So let tile equal this dot get tile xy. If tile exists, then we want to push it onto tiles. And then down here, define a random index, math.floor to tiles.length times math random. And then we'll return tiles I. So if we don't have any tiles at all, then we need to make sure we return null here. So if tiles.length is equal to 0, then we will return null. So let's add a little documentation here. All right, so back in the spawn vehicle, we want to say our starting tile is equal to get starting tile. So if starting tile is not equal to null, then we finally have a place that we can spawn our vehicle. So what's next? We need to get an origin and a destination and a mesh for our vehicle. Remember, those are the 3 arguments we have in the constructor. So the origin is going to be one of the nodes on the tile. Now, just for test purposes right now, we only have 1 node per tile. So we can just say the origin is equal to the node on the starting tile. On the destination, we need to get our origin node, and then we need to get random next node. Now we have not implemented this function yet. So what we want to do is we take our origin node and then we want to pick a destination. So that's going to be any other node that our origin is connected to. Now this may be null, so we may not be able to spawn a vehicle, this origin destination pair. But in most cases, we should find some connections. So let's go into vehicle graph node. We need to implement get random next node. To get random next node. And this returns a vehicle graph node or null. And actually, I need to go back here. This can also return null. Okay, so if this.next.length is equal to 0, we just return null. Otherwise, you get a random index. Then we return that random node. So pretty simple function. If there aren't any nodes that we're connected to, we just return null. Otherwise, you return a random one. So going back to our vehicle graph, we now have the origin. We have our destination here. So if origin and destination both exist, then we can go ahead and create our vehicle. Let's do a new vehicle here. I want to make sure it added .js. Sometimes it leaves that out. All right, so new vehicle. We're going to pass in the origin, the destination, and then we will get a random vehicle mesh from our asset manager and pass that in. So after we've created a vehicle, then we want to go ahead and add that to our vehicles group. All right, so the last thing that we need to do is we actually need to trigger this spawn vehicle method on a regular interval. So let's go to the bottom of our constructor here, and we'll do set interval, and we'll do this spawn vehicle. Now we also need to bind it to this so that when this function is called, this is in the context of the vehicle graph. And then this is going to be called config vehicle spawn interval. So let's add a little bit of console logging here. Spawning vehicle. Else maximum number of vehicles met, not spawning a vehicle. Creating new vehicle. All right, so I think we have everything we need. So let's go to the browser and see what we broke. So it renders. Didn't break it too bad. So it looks like hit maximum number of vehicles. Let's scroll up here. Spawning a vehicle. Looks like it created a taxi. Well, let's see if we can find our taxi. I should have printed out the coordinates, but. And here we go. We can see our little taxi down here. So we're spawning our vehicle now, but we're still not setting the position of it, so it's not showing up where it should be. So let's fix that by going into our vehicle class. And then let's just update our update method. And we will get the world position of our origin node, and we'll set the position of the vehicle to that position. So then we will set the position of the vehicle to the world position of the origin node. So we'll just call our update method at the end of the constructor. So now let's go back here and let's see, we need to add a .js. Looks like we have another error here. Vector3 is not defined. 3.vector3. All right, there we go. So I was able to spot our vehicle over here. So it generated way over here. So our vehicles are now being initialized to the correct position. So now we need to actually get our vehicle to travel from the origin to the destination. So before we implement the logic for getting our vehicle to travel around our graph, I'm going to introduce a concept called a cycle. Now, a cycle is basically one cycle of a vehicle going from its origin node to its destination node. That's one cycle, origin to destination. Now, when it gets to its destination, that begins a new cycle. That destination becomes the origin, we pick a new destination, and then we start a new cycle from there. So the cycle time, or the time it takes to complete one cycle, is going to depend on the speed of the vehicle and the distance between the nodes. So we're going to add some logic for the vehicle to kind of execute these cycles, to keep picking new destinations and then sort of updating its position and a rotation over time until it reaches that destination, and then kicking off a new cycle. So let's get to the code and let's try and get that figured out. So I've already started by defining the cycle start time here. So right when the vehicle is created, that's going to be the start of a new cycle. Now, when we start a new cycle, we need to gather a bunch of information. We need to get the world position of the origin node, the world position of the destination node. Then we need the vector between those two nodes. And we also need to figure out the orientation of our vehicle, which is going to be aligned with that vector between the two nodes. I'm going to create a function down here called update world positions, where we're going to calculate all that information. And we only need to calculate it once at the beginning of each cycle. We don't need to keep continually updating that every frame because our nodes aren't moving around. And that'll keep things a bit more optimal. So I'm actually going to move this code out of update and into update world positions. And since we're going to keep continually doing this, I'm going to actually store these variables with the class, so we're not constantly reinitializing new vectors for our world positions. All right, so I've defined our 4 vectors that we need here: the origin world position, destination world position, vector from the origin to the destination node, and a unit vector that's aligned with where our vehicle will be driving. So I'm actually going to call update world positions here. So I can go ahead and delete this line, delete this comment for now. Get the destination world position. Will be this as well. And then for the origin to the destination, we're going to copy our destination world position into this vector, and then we're going to subtract the origin world position. So this will be a vector that originates at the origin and points to the destination. Now our orientation vector is going to be based on this origin to destination vector. And apologies, this should be origin to destination as well. We'll copy that in there. And then we need to normalize it to make it a unit vector. And then finally, we need to align our vehicle to point in the direction of the orientation. So we'll use the same method we used before. We'll do this, quaternion, set from unit vectors. Go ahead and define our up vector. Actually, this needs to be our forward unit vector. So it's going to be pointing along the x-axis. So we're going to rotate from forward to our orientation. So wherever the vehicle is initially pointing, it'll rotate it to point in the direction of travel. Now the rotation, we're not going to update every single render frame. You could do some linear interpolation so the vehicle kind of smoothly turns, but we're not going to do that right now. But the position, we do need to update every frame. So that's going to go into this update method. So let's add some documentation quickly here. So updates the vehicle position each render frame. And this updates the world positions each cycle start. All right, now we can go ahead and implement our update method, which will update our vehicle position over time. So we're going to need to track the beginning and end of each cycle. Another thing we'll need to track is the vehicle lifetime. So the vehicle exceeds the maximum lifetime that we've defined here in our config file, then we want the vehicle to disappear. So let's do that first since it's a little bit easier. So let's define a helper method called getAge. And this is just the current time minus the created time. So in our update method, if getAge is greater than config.vehicle.maxLifetime, then we need to basically dispose of the vehicle. So do this .dispose and return. We need to implement a dispose method here. Let's go down to the bottom and add that. This will remove our vehicle from the scene and clean up all of the Three.js assets so they aren't left around. So to clean up our assets, what we need to do is we need to traverse this object. And then on the object, if it has a material, then we want to dispose of that material. This is a built-in Three.js method, which will clean up any extra materials. They won't build up over time. And then we'll do this remove from parent. This will remove the vehicle from the vehicles group that we defined right here on our vehicle graph. And that will remove it from the scene. All right, so we've handled the lifetime of our vehicles. Now we need to handle the actual cycle. This part's a little bit trickier, but it's not too difficult. So we're going to define something called the cycle time. Basically, this is a time between 0 and 1. And 0 means we're at the origin, and 1 means we're at the destination. So once the cycle time reaches 1, then we need to pick a new destination and start the cycle time over at 0. We'll define a new function here called getCycleTime. So the cycle time is dependent on the distance between the origin and destination. So the distance is really just our origin to destination vector, and then we need to get the length of that. So the duration of the cycle in milliseconds is going to be the distance divided by our vehicle speed. Since time is equal to distance divided by speed, that works out. Now the cycle time is going to be the current time minus the cycle start time. And then we're going to divide that by the cycle duration to normalize it between 0 and 1. And then finally, to keep things from kind of getting out of bounds, we're going to bound that value or clamp it between 0 and 1. So we'll just return math.min. Let's do math.max, 0, math.min, cycle time. This little expression here is just going to bound our cycle time between 0 and 1. All right, so back in our update method, let's first handle the case if the cycle time is equal to 1. So if cycle, so you need to get the cycle time. So this dot get cycle time is equal to 1. Then we need to pick a new destination and start a new cycle. Otherwise, we need to basically get the vehicle's position at where it should be within that cycle. So to get the vehicle's current position, what we're first going to do is we're going to get our position, and then we're going to copy in the world position of our origin. So that's where our vehicle is starting at cycle time of 0. And then we're going to what's called linearly interpolate to the destination world position based on the current cycle time. So if our cycle time is 0, it's just going to be at the origin world position. If we're at 1, it's going to be the destination world position. And if we're at 0.5, it'll be in between. So Three.js has a built-in linear interpolation function here called lerp. It's a really fun thing to say. So it's going to linear interpolate from the current position, which is we've set to the origin world position. So you want the destination world position here. And alpha is a number between 0 and 1. And that's the current cycle time. So let's actually pull out cycle time here. We're using the same time. All right, so that's really all we need to update the vehicle position. So I think we're at a point where we can test this code. So I'm going to add a quick little line in here. So if we hit a cycle time of 1, then I'm just going to reset the cycle start time. So this dot cycle start time equals to date now. So all this is going to do is a vehicle is basically going to just keep going back and forth between the same origin and destination. But it allows us to at least see that the cycle is working. So I'll add a log statement here, arrived at destination. And let's put a log statement in here. This is going to create a lot of log statements. I'm going to remove that pretty quickly, but at least know that this is getting called. So on that note, there's currently nothing calling the update method here. So this needs to be called every single render frame. So let's go ahead and add some logic to our scene manager. So it's actually telling our vehicle graph to update the state of all the vehicles. Let's go back to vehicle graph. And let's create an update method. So let's loop through all the vehicles. So for each vehicle, we want to call its update method. Then we need to call this each render frame in our scene manager. So each draw cycle. So let's go to the scene manager, find our draw function here. To do this dot vehicle graph update. All right, so I did a little debugging off camera, just so you didn't have to watch me go through all of that. And I did discover 2 bugs. So on this line here, line 83 in vehicle, this needs to be this dot origin to destination. And when we're calculating our origin to destination vector, we need to be subtracting the origin world position, not subtracting this vector from itself. So with those 2 bugs fixed, let's go to the browser. I think we're ready to kind of test this code out now. So we can see the cycle time kind of going through here. Let's close this and see if we can find our vehicle. Let's see one down here. And I think, unfortunately, it respawned on me. And I'm trying to find a needle in a haystack right now. So let's go and just quickly change the vehicle lifetime to 50 seconds. And here we go. Here is our taxi. You can see it's originating at this node here. It's going to this destination node and just starting that cycle over and over again like we had it set up. So in my console, I can see the cycle time going to be going over and over again. And at the end of the cycle, we see that it arrives at its destination. So our vehicle is working exactly as we expect it to so far. The next step is picking a new destination once the vehicle arrives at its current destination. So let's go back to the code and get that working and see if we can't have our vehicle driving around our entire city map. So in our vehicle class, let's go into our update method. And we're going to replace this section here with pick new destination. We're going to create a new method down here called pick new destination. So what we need to do here is we need to set the origin to the current destination. And then our new destination is going to be this.origin.get random next node. Then we go and update our world positions because the origin and destination have changed, obviously. And then we're going to reset the cycle start time to the current time. Now, one issue we might run into here is that if our origin doesn't have any other nodes it's connected to, so we could have the case where we don't actually have a destination for our vehicle. So we should add a little error handling in here in the event that the origin or destination are null. So I'm going to go ahead and add some null checks in here just to make sure we don't get into any situations where the vehicle's in an invalid state. All right, so I went ahead and added this null check to our update method. So if the origin or the destination are null or undefined, then we're just going to dispose of the vehicle and we'll just generate and spawn a new vehicle. And in our update world positions, we also check to make sure that we have an origin and destination. And if not, we'll just return early. So let's save that. And now if we go back to our browser, oh, looks like I did something. Pick new destination not defined. Always forget the this keyword, add that in there. All right, there we go. So we have our car is now traveling around our graph. That is awesome. It's probably going to get stuck here. And sure enough, we just got rid of the vehicle because this node is not connected to any other nodes. That's what the red color indicates. So just disposed of the vehicle. There should be a new vehicle driving around somewhere. This is just really fun for me to watch. I could just watch this all day. But anyways, we need to keep moving. And now that we have our graph working, we have a vehicle traveling on our graph, we can spawn new vehicles. Speaking of that, let's have a little bit fun with this for a moment. Let's update our vehicle count to 10. Set the max lifetime back to 10 seconds. And then let's see what we get. We should see a bunch of vehicles traveling on the map now. I see apologize for these being so small. I see a truck here. And there's a bus down there. Another truck here. So we're able to spawn multiple vehicles. They're all traveling independently. Okay, so the next stage of this is when we lay down our roads, we need to actually lay down those subgraphs that correspond to that particular road. So it's not particularly difficult, but there is quite a bit of setup involved with placing all the nodes for each road tile and getting all those nodes connected together. So let's go ahead and get that working. Let's create the subgraphs for each of our road tiles. When we place the road tiles down on our map, it will add that subgraph into our total vehicle graph. All right, so I'm in our vehicle graph tile class. So we're going to create some subclasses of this for each of our road types. So we have a dead end road, we have a straight road, we have a corner, a three-way intersection, and a four-way intersection. So I'm going to go ahead and create subclasses for each of these different road types. All right, so I've gone ahead and created each of those 5 subclasses, one for the dead end, straight, corner, three-way, and four-way roads. And they're all inheriting from vehicle graph tile. Now, when we're placing these tiles on our graph, we need a way of connecting them together. So if we just look at our city for a moment, obviously each of our tiles has 4 different sides. So the road tiles that are adjacent to each other, they need to be connected. Look at this 4-way intersection. We need a way of connecting this 4-way intersection to each of its adjacent road tiles. So how I'm going to set this up is for each and every road tile is going to have a set of inputs and outputs. So an input and an output node for each side. Now, not all the different road tiles are going to use all of these inputs and outputs. For example, this dead end road here, we only need an in and an out on the right side. If we do, say, a corner here, we're only connecting the input and an output on the bottom of this tile here and on the right side. But for the four-way intersection, we're going to do that on all the sides. So I'm going to define these variables for all of the sides, but some road tile types might not use all of them. And if those inputs and outputs are null, then we're just not going to connect to them. So I think that'll make a bit more sense once we start kind of connecting things together. So I'm going to go ahead and add those inputs and outputs now. All right, so I've defined the left, right, top, and bottom input-output nodes in the constructor function for our vehicle graph tile. So I'm kind of jumping over the part where I write all this code out. I realize how long this video is getting, so trying to kind of fast forward past the boring parts. And just remember that I have linked the GitHub repository in the description below. If you want to go ahead and reference the code and not kind of have to watch me type it all out anyway, that'd be a great place to go look. So we're initializing all of these inputs and outputs to null. And then in the constructor functions for each of our different road tile types, we're actually going to define the nodes that we need. So if we need to use the top, then we'll set up the input and the output node for that side. So now that we've defined these sort of interface nodes that are going to be used to connect our tiles together in the graph, we need to go through the painstaking process of defining the subgraphs for each of our tile types. Now, I'm not going to get into all the details of doing this because it'll probably take another extra hour for me to write it all out. It's really just defining the positions of all the nodes relative to the tile, relative to the center of the tile, and then defining all the edges. So connecting all of those nodes together. So we'll run through the end road tile together, and then the rest I'll just kind of fast forward through, kind of show you how they're set up, and you can go reference the source code if you need to. So I'm going to start by just giving this tile a name, just in case we need to debug it later. This will be end road tile. Now for our end road tile, go back over to our city, and I'm going to lay down these end tiles here. We need to define the nodes for the bottom side of this tile. Since this direction's up, that direction is left, that direction's right, and so forth. So we'll do this dot bottom. And we're going to find an input node. This is going to be a vehicle graph node. Then we need to set the X and Y coordinates of this node relative to the center of the tile. So I'm going to define a couple constants up here. One is called road offset. This is basically the width of one lane of the road that can kind of offset the vehicles by that amount. And then I'm going to define another variable called tile offset. This is going to be 0.25. So most of our nodes are going to be offset a quarter of the tile size from the center of the tile. And I'll kind of show you what that looks like once we finish this one up. So for the input node, let's go back here. And of course, this resets every time. So since our drivers are driving on the right-hand side of the road, our first node is going to be right around here. So hopefully you can see my cursor, but it's kind of on the right side of this road. And we're going to offset it down a quarter of the tile size. So we need to shift it in the plus X direction, so we need to shift it in the plus X direction by the road offset, which is 0.05. Then we're going to shift it in this positive Y direction. The Y axis is flipped here because Three.js is using a right-hand coordinate system. So the Y axis So the positive y-axis actually points down just because of how the coordinate system in Three.js is set up. The x will be shifted by the road offset and then the tile offset in the negative y direction. Sorry, positive y direction. This is why I'm not talking through all of these, because it does get quite confusing. And then for our output node, it's going to be on the left-hand side of the road here. So that's going to be a minus road offset. And that'll be same y offset. Now we need to define two midpoints here. So we need to define basically the two nodes where our cars can turn around at. So they'll drive up here, they'll hit this point, turn left, and then they'll come back this way. So let's define a constant called midpoint. And that's also going to have an input and an output, just to kind of use the same terminology. So the input will be shifted off by road offset, and then the output will be a negative offset. And now we need to connect all these together. Before we do that, we need to add these nodes to the tile. Let's go ahead and do that. So remember that we are adding these nodes as children of the tile, so that they inherit the tile's transform. So that all these node positions are relative to the center of the tile. So now we can finally connect our nodes together. So let's take the input node on the bottom, and then we're going to connect that to the midpoint in, and then midpoint in will be connected to midpoint out, and then midpoint dot out will be connected to this dot bottom dot out. So we're defining sort of a horseshoe shape here. So the car will come up on the right side of the road on the bottom, will come up here, go over, and come back down. All right, so before we test out this tile here and make sure everything's working, I actually need to go back and we need to remove this test node that we added. We're going to kind of blow away all the hard work that we did getting that cool graph working, but we no longer need this node. It was just a dummy node that we had. We'll go ahead and delete that. And we're probably going to run into issues with our vehicles spawning. So we're not too concerned about testing the vehicles right now. So I'm actually going to comment out this set interval function call that would trigger our spawn vehicle method. And then in our vehicle graph, we want to test out our new tile that we created. So we'll just do end road tile here. And that got the import up there. All right, so let's go see what we have here. And it looks like we have a few errors, and that is because we need to get rid of this code as well. We no longer are testing out our dummy graph, so we don't need that anymore. And looks like we still got a few errors. Not access property next, node is undefined. We also need to update our vehicle graph helper. Let's go back to our vehicle graph helper. So we no longer have the single node anymore, we have multiple nodes. So what we can do is we'll just do a for loop const node of tile.children. So the only children that a tile has are its nodes. So it's a safe assumption to make. And we'll pass in the node here. That should be all that we need to do to update our visualization. And there we go. Now it may not look like much, but if I lay down our roads here, we still need to place the graph when we lay the road down, so that's a separate step. We're just kind of defaulting to making all of these tiles end road tiles. This is our zero rotation end road. So you can see we have the input node we defined here for the bottom. This is midpoint in, midpoint out. And then this is the bottom output node. And note that this node is not connected to anything. So it's being rendered with the red material. So I'm now going to go ahead and create all of these subgraphs for all of the other vehicle tiles. And once I'm done with that, let's quickly walk through them and show you what I've done. All right, so I went ahead and created all of the different subgraphs for all of our different road types. So I'll just quickly walk through what I did and kind of show you what those subgraphs look like for each tile type. So let's take a quick look at what these different subgraphs look like. So I have straight road tile up right now. So I'll just lay down a straight road. You can see how this lane kind of connects here, goes in that direction. The other lane starts here, goes in that direction. That's pretty straightforward. Let's do the corner. So if I draw a corner in this direction, you can see how in this right-hand lane, car kind of comes here and goes through here. And in this other lane, car starts here and goes to that midpoint and then out that way. And for the three-way, connect these together in that fashion. So I'm going to change the size of our nodes a little bit so they're easier to see here. So in this subgraph, this is a bit more complex. So the car comes in on this bottom node here. It can either go straight here, and then it can go straight out. So the car's just keeping going straight through the intersection, or it can take a left-hand turn. And from here, it can just go out the top here, or it can do a complete U-turn. And we saw the car doing donuts. You can see that all of these nodes are connected together. So if we kind of get unlucky with a random number generator, car's just going to keep spinning there. So at some point, we'll need to add in some sort of history. So we'll keep track of the last 3 or 4 nodes that a vehicle has visited and not let a vehicle go back to any one of those nodes. And that would solve that problem pretty easily. And then finally, let's show the 4-way intersection. And this one's pretty straightforward. It's like the 3-way, except now we have some nodes on the bottom here that are connected in. So those are all the different subgraphs. Now we need to do 2 different things here. When we're actually placing the road tiles down, we need to add those subgraphs in. And we also need to connect the adjacent subgraphs together. So when I place 2 roads next to each other, I need to connect those kind of touching sides together, connect those nodes together with the edges. So the question now is, when we lay down a road tile, how do we get our vehicle graph to update? So if we go into our game class, see that when we are placing a building down, we are calling the apply changes method on our scene manager. So this is where we take any changes that have been applied to the city, tiles laid down, tiles removed, and we update the 3D models. So since our vehicle graph is managed by the scene manager, we'll hook into this event to get the vehicle graph to update. Let's go to our scene manager. And I already have the apply changes method pulled up here. This is going to be quite simple. If we're removing a building or we're adding a new building, then we need to update our vehicle graph. I'm going to create a new method in our vehicle graph called update tile. We'll pass in the X and Y location of the tile and also the road that was being placed at that location. Now, if we're removing a road, then we'll just pass in null and we'll handle that differently. All right, so let's do a console log statement for now, console.log. We'll start with that. And let's go back to our scene manager now. So if we're removing a road. Then we want to do this vehicle graph update tile, X, Y, and then we'll just pass in null. I need to also update the JS doc. This may be null. And then when we're adding a road, so if tile.building.type is equal to road, then we are updating the vehicle graph and passing in our road object, or the road building. So that's really it. That's all we need to add to the scene manager to get our vehicle graph updates to happen. So let me go. First, we're going to go in our vehicle graph here. And we're going to just initialize this to null. We don't need to add those fake tiles anymore. All right, so if I clear out the console, I should see something happening down here when I bulldoze a tile. I think our bulldoze only works when there's a building there. So let's start with laying a road down. You can see that it's updating the vehicle graph. And notice that when we're laying down a road tile next to another road tile, it's also updating the mesh of that adjacent tile. We've already added logic for that in previous videos, but because of how this is hooked up, it's triggering multiple scene updates. So we're actually kind of getting these extra graph updates for free. So what this means is that if we lay down a road tile here, it's going to update the mesh here, which is also going to trigger another graph update for this tile. It'll automatically handle graph updates for the neighboring tiles, which is really nice. So let's go back and let's implement out this update tile function in our vehicle graph. Close out game. We can close out the scene manager and the vehicle graph helper. And we no longer need that as well. And for clarity's sake here, I'm going to rename this method here to update vehicles. And I believe this is being called on the scene manager and our draw method. Let's update vehicles. That'll just help differentiate our two update methods. All right, so what do we need to put in our update tile method? So if we are passing in a road object, then we need to create a new vehicle graph tile of the correct type. And then we need to store that tile at the X and Y coordinates. Additionally, we need to add that tile to our graph, so it'll show up in the scene. So if road is null, then we set this to null. And finally, if we make any updates to our vehicle graph, then we need to update our helper as well. This will sort of re-render our visualization. So update the vehicle graph visualization. All right, so we need to implement this right here. So based on our road style, so let's go look at our road building object here. Based on what type of road tile we're rendering, we set the style to that particular tile. We have end, straight, corner, three-way, and four-way. So we need to create a factory function where we can pass in the road style, and it'll return the correct vehicle graph tile corresponding to that style. So I'm going to go into our vehicle graph tile, and I'm going to create a static function on vehicle graph tile called create, and then we'll pass in our road style. Then we'll need a switch statement based on the style, and we'll need to return the correct road type. Right, so I went ahead and finished out this switch statement. So you can just see that based on the style we pass in, we're creating a new instance of the correct vehicle graph tile. So for n, we get n road tile and so forth. So now we can go back to our vehicle graph. And when we are updating our tile, we're passing in a road here. And we'll do vehicle graph tile, create, then we'll pass in the road style. Now, if we go back to our browser here, once that loads, now if I place down tiles, I'm going to expect the correct subgraph to show up. And of course, we get an error. X is not defined. So let's see, vehicle graph tile. I forgot to pass in the X and Y coordinates. That's an easy fix. And we'll pass that in here. All right, let's try one more time. All right, so we have a straight road, we have the straight graph, and the end road. So we already see some issues here. We'll discuss that in a bit. Let's just keep going and lay down all the different road types. We have a corner. All of our corners there. Let's do a three-way intersection and then a four-way. So it looks like we're part of the way there. So what's going on? So the issue is that we are rotating our road tiles. I'm talking about this actual 3D representation of our road. So we're rotating that based on the adjacent roads. But we're not rotating our subgraph by that same amount of rotation. So that adds a little bit of complexity to this. We need to account for the rotation of the underlying tile. So we need to go back to our vehicle graph tile, and we're going to need to pass in the rotation as well. And then we'll need to set a rotation here. So we're going to rotate our vehicle graph tile about its y-axis using the same rotation as the road tile that it's based on. So I'll need to update all of our other subtiles as well. So I'm going to go ahead and do that. All right, so I've updated all of our subtiles, adding the rotation into the constructor here. And also updated our factory function, so we're passing in the rotation of our road there. Now I would expect if we lay down some roads, you can see that everything is rotated correctly. We have our little donut there. We'll do the three-way and the four-way as well. So this all looks correct to me. So this, you can see this is another reason why we had to make the vehicle graph nodes children of the tiles, so that we could inherit that rotation of the tile onto the nodes. So we don't have to create a completely new subgraph for every different variation of the rotation of the tile. So really the last thing that we're missing now is connecting all these little tile subgraphs together. So let's finish that part out, and then we can finally enjoy the fruits of our labor. So when we're connecting our tiles together, so the two separate vehicle subgraphs, we're taking the adjacent sides between those two tiles, and we're taking the output node from one tile, connecting it to the corresponding input node on the other tile. So if we were to look at just these two dead end roads right here, we would connect, rotate this correctly. This red dot on the bottom here, that needs to be connected to this green dot up here. And this node here at the top needs to be connected to this node. Now there are some challenges because, as you remember, we defined our subgraph for the base rotation. So when the tile isn't rotated at all, that's kind of how we define the graph. Now when the tile rotates, let's say I were to rotate this tile, say 90 degrees counterclockwise, what was the bottom edge now becomes the left edge. So the edges of the subgraph are rotating along with the tile. So that adds a little bit of trickiness, but it's not too difficult. We can handle that. When we're connecting these two tiles together, we basically need to just account for that rotation and get the correct side. So I'm going to call that getting the world side. So what is actually the left side of the tile in the world frame? So we're going to add a bunch of methods onto our vehicle graph tile for getting that side, which accounts for the rotation. So we're going to implement 4 additional methods below our create method here in our vehicle graph tile. So it'll be get world left side, get world right side, get world top side, and get world bottom side. Now in here, we're going to do a switch statement based on the rotation. So we need to make sure we're keeping track of the rotation. So I know that we're setting the rotation here, but we're converting it to radians. So let's just create a different variable called road rotation. And we'll just store the rotation of the tile in degrees right here. So going back down to our methods, we'll switch on this dot road rotation. In the event that the rotation is 0, then we'll just return this dot left. So we're returning the left side input and output nodes because the tile hasn't rotated at all. Now, if we have a 90-degree rotation, we can go back to, actually, let me do that. Let's go back here and I'll just lay a road down. So let's say I want to get the left side here. So if I rotate 90 degrees counterclockwise, that means the top, what was the top, is going to be the left side. So for 90, we'll turn this dot top. And for 180, we'll just kind of keep going around then. Turn this dot right, case 270, return this dot bottom. And then we'll just add a default case in just as a catch-all. Now we need to do the same thing for these other methods here. Let's copy and paste this in. So for the right side, we're basically just going to shift everything up. So the right goes here, and then bottom, then left, then top. So I'm going to go ahead and finish out the rest of these. All right, so I've finished out these methods. So now that we can get the correct nodes, that accounts for the tile's rotation, I'm going to implement one more method here. So when we're removing a tile from the graph, we need to disconnect all of its nodes with the adjacent tiles. So add a method called disconnect all. We're going to do a for loop here. And we'll just loop over, so this should be of. We're going to loop over each child node of this tile. And we're going to do node disconnect all. Just make sure that is the right function. Yep, disconnect all. Then we're going to remove that node from the tile. Move from parent. This will disconnect the tile from the vehicle graph. All right, so we have enough here to wire up our tiles to each other, and we can disconnect the tile when it's removed from the graph. Let's go back to vehicle graph now. So when we're updating a road tile, we first need to see if there is an existing tile there. If it is, we need to remove that before we can put a new tile in. So we'll get the existing tile using our getTile method. Then we need to get all of the neighboring tiles. So the neighboring tiles will have their own connections to the existing tile, which we need to disconnect. So I've added variables for the left tile, the right tile, the top tile, and the bottom tile. Now some of these may be null, so we'll just account for that. But we need to disconnect the existing tile and all adjacent tiles from each other. So our existing tile, we're going to disconnect that. So any outgoing connections from our existing tile will get disconnected. Now any connections from the adjacent tiles coming into the existing tile, we need to disconnect those as well. So for our left tile, and we'll throw in the question mark there. So if this is actually null, then we just won't evaluate this. We want to get the right side of the left tile, because if the tile is to the left, then the right side of that tile is touching the existing tile. Let's say get world right side. So we get the world right side of that tile, and that may or may not exist. So we'll put question mark again. Now we need to get the output node, because that is the one that is connected to the existing tile. And then we'll just call disconnect all on that. So we need to do this for all of the other adjacent tiles. So for the right tile, the left edge of that tile will be touching us. We're touching the existing tile. For the top tile, we need to get the bottom side. And for the bottom tile, we need to get the top side. So this is all the code we need to disconnect an existing tile from our graph. All right, so after we've created our tile, now we need to go ahead and wire it up to the adjacent tiles. So this logic gets a little mind-bendy, but just stick with me here. So first we need to see if we have a left tile. And we're going to do this for each of the adjacent tiles. So we need to connect the tile that we've just created to the left tile, and we need to connect the left tile to the tile that we've just created. We'll start with the tile that we've created. So we need to get the world left side, if it exists, and then we'll get the output node. And then we want to connect that to the left tile. And we're going to connect it to the input node on the right side of our left tile. And get world right side, and then get the input node. I think this is actually never null, so you can take that one out. So vice versa, we need to get our left tile, get the world right side. Then we want to take its output node and connect it to the input node on the left side of our existing tile. So we need to do the same treatment for the right tile, the top tile, and the bottom tile. So I'm going to go ahead and add those in. All right, so I've added the logic that connects all of our tiles together. So when we lay down a tile, it's going to disconnect the existing tile, and then we'll create the new tile and then connect that into the vehicle graph. So at this point, we should be able to go into the browser and we should lay down our tiles and they should all connect together. So let's see if that actually works. So I'm going to lay down a tile here and drum roll, big moment here. Boom, connected together. So I should be able to connect all these together. And that is what I like to see. It looks like everything is being connected together correctly. That's more roads out here. Let's do a four-way intersection. I think we've done all the different tile types. So it looks like our graph connection logic is working perfectly. So let's go ahead and delete some tiles, delete some roads, see if the graph updates. And it looks like it does. So perfect, we have a fully functional vehicle graph. Now we need to get our cars to travel on this thing. So there's not much more that we need to do. It's really just getting the starting node for the car. So we need to go back to our vehicle graph tile. And we need to add one more method here. So get random node. So here I'm first going to initialize an array to store the nodes in. And then we're just going to loop through each side and find any input nodes that exist. So if our left side has an input node, then we will push that node into this array. Then let's do the same for the right. So we're always spawning a vehicle on an input node. So the vehicle's coming into the tile. So if we have any nodes at all, then let's pick a random one. And if there are no valid nodes, then we'll just return null. So now in our vehicle graph, when we are spawning a vehicle, where's that? Spawn vehicle right here. So instead of node, we'll do get random node. And now we can go back and we can re-enable our vehicle spawn logic. All right, so this is the final test here. Will this work? So our city has loaded. Let's just create a very basic graph right now. I'm already seeing a few errors. See what the issue is. Cannot access property, get random next node. Origin is null. Oh, I think the issue is right here. I did lengths instead of length. So let's quickly save that change. I think that was the bug that was causing our problems there. I'll lay some roads down again. All right, so it took a few seconds, but now we have some vehicles spawning. You can see they're just kind of going around the circuit here. And they're kind of disappearing after their lifetime expires. So we still need to add in the logic for the vehicles to fade in and fade out, but that's a pretty easy thing to do. But before we do that, let's go ahead and just test out adding in some other road types here. So it looks like the vehicles are traveling along the graph, no problem. They're making turns. So there you go, folks. This is our working traffic simulation. We just have one tweak left to do, like I mentioned. Let's get these vehicles to fade in and fade out when they're spawning and despawning. So in our vehicle class, let's create a new method called update opacity. So first, let's get the age of the vehicle. And then let's create a little function here called set opacity. So we'll pass in our opacity value. So we're going to traverse over our entire vehicle object hierarchy. And then we're going to get the material on that object if it exists. And we need to set the opacity. We're just going to set the opacity to this value. Now, just for some sanitizing the inputs here. So this will clamp the opacity value between 0 and 1. So now we need to fade in the opacity as the vehicle is being spawned, and then we need to fade it out as the vehicle is hitting the end of its lifetime. So if the age is less than config vehicle fade time, I need to set the opacity, and we'll do the age, which is in milliseconds, divided by the fade time. So if our fade time is 1000 milliseconds, let's say our age is 500 milliseconds. So that'll pass this check here. So 500 divided by 1000 is 0.5. That will set the opacity to 0.5. That'll ramp all the way up to an opacity of 1. Now let's take the maximum lifetime minus the age. This is getting the remainder of life in milliseconds that our vehicle has. So if that is less than the fade time, then let's set the opacity to take this divided by vehicle fade time. So if the vehicle has 500 seconds to go before it despawns, 500 divided by 1000 is 0.5. And we'll go all the way down to 0 once we hit the maximum lifetime. So if we don't pass either of those conditions, so we're not in that fading regime of the lifetime, then we'll just set the opacity to 1. Now we do need to update this every draw frame. So after we've updated the position, we will just call update opacity. And I forgot, you can't put an optional operator when you're doing an assignment. So we need to do a null check this way. For object as a material, then we'll set the opacity of it. All right, so let's go ahead and create a road here. And we should see our vehicles fading in and fading out. So I saw that truck faded in. Let's watch it for a bit and see if it'll fade out of view. Looks like it just despawned pretty quickly there. Let's watch one more. And sure enough, it looks like I forgot to put a vehicle here. So that should fix that bug. All right, so this truck just faded in. Let's watch it for a bit here. And there we go, it faded out. All right, so that is it. That is the complete traffic simulation. We have our vehicles fading in and fading out now. And we can create any arbitrary road system that we want to. Our vehicle graph will automatically update all of the connections between the different subgraphs and the different tiles. So I just want to enjoy our product here without the graph being visualized. I'm going to have it in my history. We'll set the visibility of our vehicle graph helper to false, and there we go. Now we can add a few buildings in, pretend that these vehicles are traveling in between all these buildings. And there we go, our city is starting to look alive. So I know this was a really long tutorial, but this is one of the more complex topics. I think the most complex topic I've presented on. So hope you're able to follow along and get this working for yourself. As always, I've linked the source code in the repository, so feel free to go check that out. I'm also running a GitHub page, so you can go and just test this out live. So thank you so much for tuning in. If there's any other features that you would like to see in this series, please leave it in the comments below. And don't forget to hit those like and subscribe buttons. It just encourages me to keep creating more content. So thank you so much, everyone. And until next time, keep on chilling, coding, and creating.